Hi, everybody. My name is Trevor Spires with howtoNSX.com, and today we are taking a look at Avi Networks, where the NSX Advanced Load Balancers integration, brand new integration with NSXT, the core software-defined networking platform from VMware. This is actually going to be a three-part series. Today, part one, we're just going to do a quick overview of the integration and kind of how it works, what makes it different, why it's unique, maybe compared to how you would have configured a Avi load balancer in the past. And the second part, I'm going to do a deep dive on kind of some of the things I learned. It took me a few days to get this running, just because I was, kind of learning along the way. So I want to make sure that you don't spin those cycles trying to get the system running. I want to make sure that give you some lessons learned. That's going to be part two. The third video coming is going to just be basic setup. I'm going to walk you through the installation, the configuration, end to end. That way you can get this thing running in your production or lab environment. So with that said, let's get started. I just want to set the stage for what this is, what this integration between NSXT, the SDN platform, and Avi Networks, i.e. NSX Advanced Load Balancer. You'll hear the load balancer referred to under both names right now. So VMware bought Avi, the company, back in 2019, and ever since then they've been slowly integrating the platform into NSX. So up until now, it's August 15th, and like this last week the integration dropped. But up until now, the two platforms, NSX and Avi Networks, really have just been associated by name, right? They renamed Avi, rebranded it as the NSX Advanced Load Balancer, but still was kind of a standalone platform. Now is really the first big step in the marrying of those two together, the integration of those two platforms working with one another and kind of complementing one another. So it's a big step forward with the kind of overall vision of what VMware is doing with NSX and Avi. Really, in terms of what the integration brings to the table, other than just like, okay, cool, it's integrated, right? But it does two big things. It expands the current feature set of NSX. So if you're an NSX customer, an NSX user, really it kind of takes load balancing to the next level for that platform. Right now, the current load balancer has really some kind of basic features. We call it maybe a basic load balancer. It can do some pretty cool stuff, but definitely can't expand out to do like global load balancing, like DNS load balancing, no WAF. There's a lot of things that it's kind of missing. No auto elasticity like you get with the NSX Advanced Load Balancer or Avi, right? So that's a big reason that I think VMware is doing this. It just adds a lot of value to the NSX platform. And then really what it does for Avi is it changes, for me anyway, the way I'm thinking about it, because traditionally I've thought of the Avi load balancer as a north-south load balancer, being like a point of egress and ingress to your data center. And that's kind of how Avi has positioned the platform for a long time. They go after web app companies, big SaaS type companies with the product because it has the ability to scale really massively. But this change, this integration with NSXT is really cool because certainly you can still use this as a north-south load balancer with NSXT, but also you can really leverage and harness the power of Avi now as an east-to-west load balancer in this sort of configuration and design. And you could have done that before, standalone Avi, but it just would have been a little more challenging. And again, it's not really how it was marketed before. But now I see this thing really being north-south, east-west load balancing when integrated with the NSXT platform. So I think that's it for an overview. I'm going to stop showing you this picture of my face, and I'm actually going to just share my screen with you. And we're going to take a quick look at the platform and kind of what it is and how it's working, how this integration between NSXT and Avi actually happens. So I want to show you two quick docs before I go too deep into the integration. First of all, this document right here that I hope you can see is the installation guide, excuse me. So this is going to be where you start. If you want to get this stuff stood up in your environment, this is a really awesome step-by-step walkthrough of how to get this thing up and running. I'm not going to really go into it right now. I just want to make sure you see the URL and that you can go there. And then if you are on the Avi Docs website, you could also search for it, but just make sure that you're searching and that you're navigated to version 20.1. This is the newest release of the Avi platform, and this is the only one that supports this integration. So if you have Avi already, you're going to need to upgrade to 20.1. And if it's a fresh install, cool. Just make sure that you're doing a fresh install of the latest bits, the 20.1 bits for this platform. So I want to show you this page. I also want to show you this, and I'm going to show you some pictures from this guide, but this is the NSXT design guide for Avi Networks, or the NSXT advanced load balancer. For the rest of the video, I'm just going to call it Avi, but know that it will be referred to as either. Avi, to me, is just kind of easier to say, so that's what I'm going to call it. This is the design guide. I would highly recommend you reading through every word of this if you're going to use this in production. It's not that long, but it's worth and a lot of really valuable information on both of these pages. So if it's in production, read through these extensively. If you're just throwing it in a lab, hey, ignore it and then see what happens. But you're going to wish you read it, because I didn't read it. I just tried to set it up, and I wish I would have spent more time reading up front. It would have saved me in the long run. So I think that's really it. Make sure you're running NSXT 2.5 or 3.0, and then you need to be running vCenter 6.7 or 7.0, because the integration, it's kind of a three-way integration. The Avi controller integrates with both NSX and vCenter at the same time in order to automate some of the deployments. So pretty cool stuff. So let's go ahead and get to it. Let's get to the overview of the platform. The logical place to start is the architecture, okay? How does it actually work at a kind of high level? Well, a few things that we do, right? You need to install the controller. This is an OVA if you're doing this on-prem. I'm doing this all on-prem because this is an NSXT, so usually that's going to be an on-prem deployment. Sorry, it's NSXT integration, so generally that's going to be on-prem, right? So the Avi controller is the kind of control plane, the GUI, the queen bee, right? The thing that manages everything. So it actually plugs into NSXT via API, and also it plugs into vCenter via API, right? So it's pretty cool. They know about each other, and that's what allows this integration to happen. vCenter can kind of send notifications back. And then the only other thing to note, right, is the Avi service engines. These are the worker bees. These are the actual data plane, the load balancing fabric that you would be deploying. So these need a management connection back to the controller, right? So that's really it. It's not like a super complex architecture. Really, all it is chaining vCenter, NSX, and Avi controller together in order to allow for the integration of the load balancer. I mentioned that there is a requirement to have management connectivity between the Avi service engines and the Avi tier 1. I'm sorry, not the tier 1, sorry, and the Avi controller. First of all, I would recommend go through the design guide and the install guide to figure out the ports and protocols necessary, because if you're using a firewall, you may need to allow those ports and protocols, not just from the service engines, but from NSXT to Avi and from vCenter to Avi and vice versa. So just make sure that if there's a firewall that you've paid attention to that. But there needs to be a management connection between the service engines and Avi controller, because Avi will constantly be pushing configuration down to those service engines. So it's not too difficult to do. One requirement as of today, though, is that if you're doing this integration, the service engines need to be on an overlay segment in NSXT. Okay, it's not really depicted here, but you can kind of assume it's an overlay segment because it's under the tier 1, but it does have to be overlay, right? So that means you need to have NSXT overlay networking functional really before you even begin thinking about deploying Avi on top of NSXT. So that's really it. You just kind of Avi will automatically deploy it to those that overlay segment, and you'll see that here in a little bit. Nothing too crazy, and I'll show you that in, I believe, the second or third video that I make about the NSXT and Avi integration. Okay, this is the cool part, right? Here is like from a traffic flow perspective, from a really the data plane, how this works. There's two different deployment models for the service engines. Again, those are the data plane of the Avi Networks platform. These are the worker bees that are moving packets back and forth between your applications and your end users. So the two configuration options are this. Option one is that you can actually have your service engines be deployed on a standalone segment. And when you look at the diagram, you might think, if you're not familiar with NSX, you might look at this and think, that seems kind of inefficient. Why would I do that? Actually, it's quite efficient. Because of NSXT, it might look like we would be like hairpinning traffic up and down between my service engines and my load balancer. But if you think about it, right, NSXT, the whole idea is that we're distributing routing down inside of the hypervisor, right? And because we're doing that, even though it looks like we might be like hairpinning traffic up and down, this is actually a really efficient path for the data to take, because if your client connects to a VIP on one of these Avi service engines, it's going to be routed over to another segment, all connected to underneath the same tier 1 router. That way, it's really all east to west, and even the packet could stay within a single hypervisor the whole time if you had it configured that way through like affinity rules or what have you. So this is option one. It looks a little funky in the diagram, but it's actually quite efficient, and I wouldn't be scared of using this method. If I was doing a large scale deployment, I would probably consider this method because then I could have a whole segment dedicated to be my VIP network, and then I could have a number of different back-end segments connected to my tier 1 gateway to load balance 2, right, on my back-end servers. So that's option one. Option two is what we see on the right-hand side here. So this is what I've done in my lab, and this is probably the simplest, most straightforward configuration. And this configuration actually would be, you put your service engines on the same logical segment, the same overlay network as your servers, right? That's what I have, and it's a pretty straightforward deployment. I did it because it's just kind of easier to stand up and quicker to configure, but you can do either of these options. It really, truly does not matter, okay? So the only thing, what else do I want to say about this? Yeah, it might be self-evident, but I want to make sure this is clear, right? If you see this configuration, one thing to note is that the service engines are in what we would call like a one-arm mode, right? That means that from the end user, the packet is going to go through your physical network into your tier 0 router, down to your tier 1 router. It's going to go into a virtual interface, a VNIC, on the Avi service engine, and then it's going to go right back out that same virtual NIC to hit your server, okay? And then the return traffic actually will go through the Avi service engine and then back out to your client, because there's a NAT taking place at the service engine. And I don't know necessarily why it is, because if you're using Avi as a north-south load balancer, for example, you can have these service engines kind of function as a router. They can have a leg in 2 different networks, but the way it works here is it is in a one-arm configuration. And so not a big deal at all, but something to note, right, is that it's not going to be these service engines are not functioning as routers, really. They're functioning as a one-arm load balancing. And you can put multiple different VIPs or different services on the same service engine. And what I've read in the documents, I haven't tested this yet, is that it'll actually add an additional interface to that if you do that, and then it'll put the interface in its own VRF. That way you can just make sure that you can still consolidate VIPs on top of the service engine, but the traffic would be separated between your applications, which is a good thing from a security perspective. You don't necessarily want them all to be on the same VRF, right? So I think that's it for this. Again, these are the 2 deployment options, the 2 kind of design options for this integration. Okay, this to me is one of the most exciting parts about this integration. Okay, so Avi, kind of one of the fundamental values of Avi is that it can be an elastic load balancer, it can auto scale, and it can do active-active up to like 64 different service engines. Well, when you configure a load balancer in Avi that's integrated with NSXT, what's really cool is that it will automatically add static routes from your tier 1 router down to your service engines, right? So it's automatically going to set up ECMP. If you compare that to like a physical network with this deployment, you can still do it, but the challenge is you need to like have some kind of BGP configuration or like some kind of automated, potentially, I guess maybe static routes on the physical. I haven't done that config, but it's a much more challenging setup. With this, we actually auto ECMP it for you. So that auto scaling feature is really simpler than ever with this integration. So that's pretty cool, is that we will just, and I'll show you that in one of my other videos, is how the NSXT tier 1, it's being manipulated by the Avi controller. So because of that, it's pretty easy to just add additional next hops that are the service engines. Yeah, pretty straightforward. So that's cool. That's what I would recommend. I'm not going to recommend anybody do a deployment other than the ECMP deployment, because to me, it's too easy to set up, and the benefits are too massive, right? Because with this being active-active, you could lose the service engine and be totally fine, right? We would stay alive. But you do have one other deployment option. And by the way, this deployment option would be relevant for either an active-active configuration in Avi or what we call an N+M configuration, which is kind of like a basically active-active, but with some buffer space. That is relevant. Both of those settings in Avi would be relevant here. That this is what you would see if you were doing it on top of NSXT. Now, for people who maybe don't want to do that, I don't know why you would not want to do an active-active deployment, but you do have the option to do active standby. So in an active standby deployment, obviously only one service engine is going to be available at any given time. So we still use this concept of a static route here. That this will be a static route injected into your tier 1 router, but it's only sent to one service engine. Obviously, you do not have to ECMP because you're not doing active-active. So that is one other option here. In this configuration, right, your tier 1 routers, and this is in the design and in the install docs, your tier 1 routers, they're actually going to be redistributing these static routes, right? So as Avi service engines get spun up and down, the static routes are actually going to be added and removed, and then those are going to be advertised upstream. So that's pretty cool. So what that means is when you create a new VIP in the Avi controller, you don't need to do any routing. You don't need to change anything. That's going to be automatically advertised upstream because that static route is injected and redistributed from the tier 1 gateway. And that's part of the setup process, is to be redistributing routes from the tier 1. Here is the last thing I'm going to show you. Be careful though, because this is not technically in the product yet. They have this, and I'm recording this video as of August 15th, I mentioned. They have this slide in the design guide, and the design guide basically says, hey, by a form of automation, right, the Avi controller is going to automatically configure the distributed firewall policy inside of NSXT to allow all of the necessary communications for the system to run. That's what the document says. But if you go back and read the fine print, what you'll actually find is that while it's a very pretty picture and a very cool idea, it is not fully integrated yet. My guess is that they tried to get this integrated in this release, but it probably just didn't quite get there. But if you read this note, it will mention that this idea of us automatically configuring the distributed firewall policies, via the deployment of a VIP or the service engines does not happen. They do create the networking and security group. So they do put your service engines and your controllers and everything into a group in NSX, and then you could build policies off of that manually right now. But As of today, the creation of distributed firewall policies do not exist. So if you're reading through this, don't be confused. Even though the picture's there, it's not supported just yet. My guess is that's probably going to be in the very next release, given that it's in the doc, but has this note that it's not supported. Okay. I believe I've covered all the high-level stuff that I want to cover about this. So what I'm going to do now is just take you into my environment and show you what this actually looks like from an operations perspective, right? So I'm logged into my lab, and I'm looking at, first, let me show you the controller, okay? So let me get logged into my Avi controller here, and perfect. So I'm going to do a little drop down. So I'm logged into my Avi controller, and I just have one VIP, one virtual service configured, right? It is called my first virtual service, and very basic, just a 443 load balancing to 2 backend web servers, right? I can actually show you. It's just some silly database that somebody at VMware made that you can use. This is the same database in the hands-on lab. But yeah, it's just a quick database, and it's load balancing between two web servers, right? So basically, what happens when you configure a VIP in Avi after you've set up the system and done all the integrations is that Avi automatically deploys these 2 service engines, right? Again, a service engine is the data plane. So I can even show you in my vCenter. These service engines are automatically deployed by Avi. In fact, on the back end, what happens is the controller uploads the OVA to a content library, and then will automatically deploy service engines. So that is cool, because now if we needed to scale out, for example, so if I go into the virtual service and I wanted to do a scale out event or a scale in event, I could do that, and they would just deploy an additional service engine to give me that elastic level of throughput. I could also automate the scale out or scale in. We're not going to go into that today. So that's really it. I mean, it's a basic config. I'll make another video to show you how to actually configure this, but pretty straightforward, right? So that's all it really is from an Avi perspective and from a vCenter perspective. Now, in NSX, it's a little bit different. In NSX, there's a few things that happen when you configure Avi and when you configure a VIP into your NSX cloud. And that's let me take you back and show you one more thing. In the controller, if I were to create a new virtual service, after you configure NSX, you'll actually be presented with the option to deploy this to your NSXT cloud, right? So if you're familiar with Avi, you would have seen maybe Amazon and Azure and your vCenter cloud here in the last version that you were using. But today, we can actually go straight to NSXT, and that's how you tell the controller where to deploy the VIP that you're configuring. So when I configure a VIP, what happens in NSX? Well, a couple of things happen, okay? The first thing that happens, well, I don't know if it's the first or second thing. It's all automated, so it all happens really fast. But one of the things that happens is that Avi is going to automatically create these networking and security groups. So don't edit these. I haven't tried editing them, but these are where you put the virtual service, the management VIPs, the service engines, all that good stuff is automatically created. And then you can click here and I can see, hey, look, that's my Avi controller. I can look in and also see my service engine management IPs and my service engines, period, right? So that's all automated. If you wanted to, you could go in and add these to the exclusion list or add firewall policies to support these groups. But right now, the groups are just added and nothing else really happens, okay? The other thing that happens is that in NSXT, when I deploy it, remember that diagram we were looking at before with the tier 1 gateway and the service engines and how we would do ECMP to load balance traffic? Well, that also happens, right? So if I were to go into my static routes under my tier 1 gateway, the Avi system will go in and go ahead and configure a route, and the destination of the route is actually my VIP, right? Because this VIP it will live on every load balancer. So this 172.16.10.20 VIP actually if I were to look here in vCenter, both of these service engines are listening on that IP, right? So this is part of what makes this elastic and scalable, right? Because I can have one IP, one VIP live on multiple service engines at the same time. And I have two here, but again, we could scale this out massively, right? So that happens. And then the next hop is going to be the IP of the service engine itself, right? So this is what allows me to, again, this is part of the configuration for that scaling, is that as service engines are spun up by Avi, we would actually see a new route added. And maybe I can, I'm not going to show you that now, but basically it would add a new route. So it pulls the IPs from a pool. So if I were to add another service engine, you would see the exact same configuration, but we would just have another next hop that is 172.16.10.102, right? Because it pulls IPs in sequential order. So, okay, so what did we do, everybody? Let's kind of rethink everything that we walk through here, right? I showed you these design guides and the install guide. And again, I would highly recommend that you read through these if you're going to deploy this in production. You've got to understand the integration and how it works. So look at both of these documents, read through them at least once to understand what's going on. We walked through some of the architecture components, how this thing works, how it does ECMP, and then I showed you in the lab really what this thing does, how it works, and how the Avi controller manipulates vCenter and NSX to make this a really automated process. The experience of deploying and creating a new virtual service is really, really very easy with the integration that has been added to the product. So that's all I have for today. That was the overview of Avi Networks, and stay tuned. I'm going to make another video where I walk through how you would configure a VIP and kind of what happens. I'm going to show you the process that is automated when you configure that VIP, and then talk through some lessons learned that I figured out while I was configuring this thing for the first time. And then I'll make a much more straightforward video of just the installation and configuration of the platform. So I hope this was helpful for you. If you have any questions, please, as always, if you're watching this on YouTube, the comment section. If you're on my blog, the comment section, ask me a question. And my contact info is on howtoNSX.com. If you'd like to reach out to me individually, you can go right there, and I'll keep an eye out for you. So thank you again for sticking around, and happy load balancing out there. All right. Bye, everybody.